Hello, everybody. I am going to show you how I might think about problems 2, 4, and 6. And then I'll put timestamps in the video so that if you want to skip ahead to one, you're welcome to do that. Okay. We did number 1 together in class. So this is where I'm going to start. There's some things in the way. I think I'll just, okay. Those things are still helpful. It's just in the way. Okay. Here we go. The graph below shows the weight of a baby elephant, where X is the time in weeks since the elephant's birth and Y is the weight in pounds. At 4 weeks, the elephant weighed 352 pounds, and at 12 weeks, the elephant weighed 592 pounds. Label the axes of the graph. Okay, so the first thing I'm going to do, it says X is the time in weeks, Y is the weight in pounds, so I'm going to put that here into my graph. X is the time in weeks. And Y is the weight in pounds. Okay. At 4 weeks, elephant. So here they're actually giving us this clue in 2 places. They're giving us the clue in the table or in the explanation. They're also showing it for us here on the graph. And then they're showing us 12 weeks, elephant weighed 592. They're telling us that here on the graph too. In class, I saw a lot of people trying to guess what that value is. I would not use the graph to estimate it because they give me 2 clues. I would use the clues that they give me and then calculate that because we'll get a much more accurate answer if we do that. Okay. I'm going to make a table because I like to make a table strategy. And I write a lot neater if it's a little bit fatter. There we go. So remember, X is the time in weeks. And Y is the weight in pounds. Okay, so here's my table. I want to know, like this is a value that I want to know, so I'm putting it in my table, but I don't know the number yet. The next number that I'm going to put in my table is 4 and 352. And the next value I'm going to put in is 12, 592. If you want to expand this table out and put in some more numbers, you're welcome to do that. For the interest of space, I'm not going to choose to do that. Okay. So change in Y from 4 weeks up to 12 weeks, he gained, I don't know, 592 minutes. If I had a calculator handy, I'd use it, but I don't. Okay, 240. So this little baby elephant grew 240 pounds from 4 to 12. 12 minus 4 is 8 in 8 weeks. That's okay. Okay. And this is my change in X. Oops. Change in X. So when I go to find the slope is the rate of change. And remember, a rate is a number that describes the ratio relationship between 2 different variables or 2 things that have different units. So I've got, this baby grows 240 pounds in 8 weeks. So that's my slope, or the rate of change. So it's 240 over 8, but it's 240 pounds over 8 weeks. That means 240 divided by 8 is 30. So that means that it's going to grow 30 pounds each week. Or per week, 30 pounds per week. So then I can use that information. Let's move to this color. So in 4 weeks, it will have grown 4 times 30, because it's 4 weeks and 30 pounds every week, which is 120 pounds. So 352 minus 120 would be 232. So 232 pounds. And this tells me like it's birth weight. Okay, so let's see if that helps us do the rest of this problem. Oh, do numbers 1, 2, 6 on this. We're doing it. Okay. So let's see here. So the equation is going to be y equals 30x plus 232. Oops. 232. It's 30 because it's 30 pounds each week. This is the slope. 232 pounds is the birth weight. That's the b. And y equals mx plus b. So the graph and the equation to tell the story of this elephant, there are two important parts of the story that must be there. Anything else is extra and delightful. So it was the elephant weighed 232 pounds when it was born. It is growing at a rate of 30 pounds per week. Okay, those are the two things I would want to see. It's 232 pounds when it was born. It's growing at a rate of 30 pounds per week. And then there's the equation. All right, cool. So that was question 2. Question 4. Peter is draining his hot tub so he can clean it. He puts a hose in the hot tub to drain the water at a constant rate. After 5 minutes, there are 430 gallons of water left in the tub. After 20 minutes, there are 370 gallons of water left in the tub. X is time in minutes, and Y is the remaining water in gallons. Okay, so first of all, I'm going to use my number sense. It is draining the hot tub, so that means that the rate of change, or my slope, is going to be negative, because the amount of water is decreasing. So if I don't get a negative rate of change, that means that I'm putting water into the tub, which is not the situation. So just keep that in mind. We expect our rate of change to be negative. I'm going to do another table. I like tables. I think they're really handy. After 5 minutes, okay, right. So I've got X is time in minutes. Time in minutes, which is X. And Y is volume in gallons, which is Y. And I don't know at 0, but I do have 2 clues. After 5 minutes, there's 430 gallons of water left in the tub. And after 20 minutes, there's 370 gallons of water in the tub. So I'm going to use those clues and just put them 5 minutes, 430 gallons, and 20 minutes. Oops. I don't normally put in the middle values, but if you really want to, you can. So 370. It kind of depends how your brain sees patterns. And if your brain needs to see it going 0, 5, 10, 15, 20 to see the pattern, then go ahead and do that. But just know that like this number and this number, I don't need them to solve the problem unless I need them to see the pattern. Okay, so From 430 down to 370 gallons. 430 minus 370. 43 minus 37 is the same answer as 46 minus, is that 6 gallons? Yeah, it goes down 60. Okay. That was just my mental math. Okay. So it decreases, oops, what's going on? It decreases 60 gallons. And how long did that take? That took 15 minutes. Sorry for my stuffy nose. Okay. So if it goes down 60 gallons in 15 minutes, I'm going to divide that down. That means it goes down in 1 minute. It goes down 4 gallons. It goes down 4 gallons. Okay. So that means that my slope, or my rate of change, is negative 4 gallons per minute. So that means in 5 minutes, it goes down 20. So 410 goes down 2390, goes down 2370. So I don't need those two values, but they kind of prove that the pattern is correct that I found. Okay. So then going this way, in 5 minutes, from wherever I started, I go down 20 gallons, which means that I had to have started at 450. Okay. And this is my y-intercept. All right, so my equation is y equals the slope, negative 4 gallons per minute times the number of minutes, plus 450. A lot of people prefer to do it this way too, and this is also correct, totally fine. You can do y is the water remaining, so the amount of water there is in the gallon, or in the tub, because that's y. So the amount of water you have started at 450, and then you're subtracting 4 gallons every minute. It's exactly the same thing. For some reason, sometimes people find this one a little easier to work with. You can choose. Use your equation to add more details to the story of Peter draining the hot tub. These are the clues that I need to see. The full tub was 450 gallons. It's draining at a rate of 4 gallons per minute. Okay. Any other details is fine. The table below, so problem 6, the table below shows the height in feet of a hot air balloon as T minutes after it takes off from the ground. It rises at a constant rate. Okay, if you want to, T, H, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you want to do a nice long table, you're welcome, happy to do that. I know that this is 300. I know 5 is 750. And I know 9 is 1,350. Okay, let's figure out the other ones. So from 300 to 750, that goes up 450 feet. And that goes up 450 feet in 2 plus 3 is 5 in 3 minutes. So it goes up 450 feet in 3 minutes. that means it goes, 150 feet per minute. So 300, 450, 600, 750. I could keep going. I don't want to do that mental math. Going backwards, 300 minus 150 is 150. 150 minus 150 is 0, 0. Okay. So the equation, the height in feet is 150 times time. If you wanted to, you could do y equals 150x if you renamed the time in minutes for x and the height in feet for y, if that's something that it helps you. You're also welcome to write, you don't have to, so I'll do it maybe in, I don't want any of those colors. So this, I could also do like +0 if you want to, but you don't have to, because adding 0 doesn't really change the story. So this is the equation. Use the table and the equation to tell the story of the hot air balloon. It starts on the ground at 0 feet, which is on the ground. Oh, it starts. Sorry. It starts on the ground, which is at 0 feet, and then rises at a rate of 150 feet per minute. Okay. I hope you find that helpful. Problems 1, 2, 3, 4, 5, and 6 are due on Friday. And good luck. Okay, bye.